Now we look at intercepts of linear equations in two variables. Before we do that, we better define what an intercept is. So we begin with an x-intercept. An x-intercept is a point, ordered pair. Okay, points are ordered pairs when we're talking about two dimensions, where the graph touches the x-axis. Doesn't have to cross through necessarily, but touches the x-axis. This is a general definition. Similarly, you can probably guess what a y-intercept is. It's also a point, but it's where the graph touches the y-axis. All right, so let's practice with this basic concept. Okay, I've got 3 lines graphed, and I want to determine the intercepts of each. So in this particular line, the x-intercept is where the graph touches the x-axis, which would be right here at this point, which is the ordered pair -2, 0, because the x is left 2 and the y is 0, not off of the x-axis. The y-intercept is this point up here. X is 0 and y is 2. For the second example, the x-intercept is the point where the graph touches the x-axis, which is right here. X is 3, y is 0, so the ordered pair 3, 0. The y-intercept, well, this is a vertical line. Hopefully you can tell my intent that this is supposed to be a vertical line which will never touch the y-axis, so there is no y-intercept. Last example, the x-intercept, well, this is supposed to be a horizontal line which runs parallel to the x-axis, so it will never touch, so there's no x-intercept. And the y-intercept is down 5, so that's where x is 0 and y is -5. Okay, so those are some quick, simple examples. Now, I want you to notice a pattern here. In x-intercepts, notice that the y is always 0. You have an x value followed by a y value of 0. That's because when you're on the x-axis, you don't have a y value. You don't have a vertical measurement because your vertical measurement's 0. So every x-intercept has a y value of 0. And similarly, if you look at a y-intercept, you get an x value of 0. That's because every y-intercept does not have a horizontal component. So every x-intercept has a y value of 0. X doesn't have to be 0. X is the unknown. X is the thing we're trying to define. Right, because when we're looking for an x-intercept, we're scanning the x-axis for where the graph touches, and that's at -2. That was the unknown. We know y has to be 0. Over here, we scan the x-axis to see where the graph touches, and we see that x is 3. So when you want to know x-intercepts, you need to figure out the x value. When you want to know y-intercepts, you need to figure out the y value. Okay, so that's important. You want to know x-intercepts, that means you're searching for x. That means you have to know y, so y would be 0. When you want a y-intercept, you don't know y, that means you do know x, which is 0. So let's practice this with equations now, because as we know, these lines represent equations, or equations represent these lines. So we should also be able to find intercepts when we have equations. Okay, so I want to determine the intercepts of each of these. So let's start by finding the x-intercepts of each. If I want to know the x-intercept, that means I'm searching for x. That means I must know y, and I know that y is 0. So I plug 0 in for y to the equation. And then I can solve for x. I can determine x. So 3 times 0 is 0, so the left side is just 2x minus 0, which is, of course, 2x. And then if I divide both sides by 2, I get x equals 0. So that means my x-intercept is the ordered pair where x is 0, because I just figured out that x is 0. And my y value is also 0, because on an x-intercept, y is always 0. Okay? So my y-intercept, I plug in 0 for x. So I get 2 times 0 minus 3 times y equals 0. So I've got negative 3y equals 0. Divide by negative 3 and I can see that y is 0. So my y-intercept is the ordered pair where y is 0. And since it's a y-intercept, I know x is 0. I plugged in 0 for x initially. So now I've got my x-intercept and I've got my y-intercept. Notice they're the same. The only time they can be the same is if they're both 0, 0, because 0, 0 is on the x-axis, but it's also on the y-axis. So it's not very common that they both have the same intercepts, but in this case they did, which is fine. Let's look at the second equation and determine the x-intercept. I need to plug in 0 for y. There is no y, so there's nothing to plug in. So I rewrite my equation, and I can solve for x, divide both sides by 3, and I get 5/3. So my x-intercept is the ordered pair 5/3, because x is 5/3, and y is 0 for an x-intercept. If I want to figure out my y-intercept, I plug in 0 for x, and I get 3 times 0 equals 5. So I get 0 equals 5. There's nothing to solve for, right? And this is actually a false statement. So there's no way I can figure out a y value. So there is no y-intercept in this case. And we know that can happen because sometimes the line doesn't touch the y-axis. Okay, last example, x-intercept. I need to plug in 0 for y, and I get 0 minus 4 equals 7, or I could say negative 4 equals 7. I can't solve for x. There is no x. And this is false, so there is no x-intercept. The y-intercept, I plug in 0 for x. There is no x to plug it into, so I just copy my equation and solve for y by adding 4. And I can see that my y value is 11, and for a y-intercept, x is 0. And that is how you determine intercepts from a graph or from an equation. Plug in 0 to the appropriate spot and solve for the other. Now, I don't encourage you necessarily to memorize this key idea here that we talked about. It is very important. Think about x-intercepts. Anything on the x-axis, y is 0. Y-intercepts are on the y-axis where x is 0. So it is really important. Find a way to remember it for yourself. If you have to memorize it, do that, but I would rather you be able to think about it and figure out which one's 0 in each case.